Alright, hello everyone and welcome back to my YouTube channel. In today's video, we will continue talking about factorization. In our previous videos, we have explained basic factorization, the difference between two squares factorization, and factorization when we have perfect squares. Now, just so that we can continue with the lesson and do more complex and more difficult examples, I would like us to revise basically these three ways and methods here. So, basic factorization. If we have an example like this, 6x squared y and then minus, let's say, 3x. Now, what do they have in common? Do they have anything in common? Oh yeah, they do. Both of them have 3x in common, so it's their common factor, right? So 3x multiplied by what will give us 6x squared y. 3 multiplied by 2, x multiplied by x, and there is y missing. Minus 3x multiplied by what will give us 3x. Oh, it's only 1, right? So that's the final answer. Then we did factorize the difference between two squares. So if we have, for example, 25x squared minus 4y squared. Okay, the reason why we apply difference between two squares because we have something squared minus something squared. But what is that actually? What number to the power of 2? Or what did you multiply by itself to get 25x squared? Oh, we multiplied 5x by 5x. And then again, what did you multiply by itself to get 4y squared? We multiplied 2y by 2y. So this means that we can say, finally factorized, it's 5x minus 2y and 5x plus 2y. All right, and the final example we covered as well. Let's say x squared plus 10x plus 25. Okay, what do we have here? This looks like what number to the power of 2 will give us x squared? It's x, right? And then what number to the power of 2 will give us 25? It's 5. We copy the sign from here, so it's x plus 5. You can always double check by using the formula. The formula for this perfect square identity says first squared, which is x squared, 2 times first times second, which is 2 times x times 5, which is 10x, finally plus second squared, which is 25. That's how we know it's correct. But what if our question is, for example, x squared plus, let's say, 8x plus 15. Okay, first of all, do they have anything in common? These three terms here, do they have anything in common? Can we use method number 1? No, they have nothing in common, right? So method number 1 cannot be used. Does this look like difference between two squares? Like this one here? No, so this method cannot be used. Okay, is this a perfect square? What number to the power of 5 will give us, to the power of 2 will give us 15? Oh, doesn't work. So this method doesn't work for our example as well. Then what is it? In order to explain that, I'd like us to do something first. That something is called factorization by grouping. Okay, what do we mean by that? Factorize by grouping. If we have an example like this, AB plus AC plus BD plus CD. Okay, now we say, wait, we have 4 terms. Do we have something in common from all 4 of them? No? All right, then what do we need to do? Let's try the first 2 terms. Do they have anything in common? Oh yeah, they have A in common. Excellent. What do we have in brackets? In brackets we have B and we have C. All right. Then we say the the other two, what do they have in common? BD, CD, oh, they have D in common, right? So what do we have from the first one? D multiplied by B is DB. D multiplied by C is CD. All right. Now my next question is, the first term and the second term, what do they have in common? Oh, don't you notice that B plus C and B plus C is in common for them? So B plus C goes out. When we take B plus C from the first one, then what's left? It's A. When we take B plus C, let's just close this. When we take B plus C from the second one, then what's left? Oh, it's only D. So the final answer would be this. All right. Let's try another example without using any formulas, okay? What if we have 3x squared plus 4x plus 33x plus 44? Okay, it's four terms, so we do grouping here. First two terms, what do they have in common? Oh yeah, they have x in common, right? X multiplied by what will give you 3x squared? It's 3x. X multiplied by what will give you 4x? 4, right? Okay. Now, these two here, what do they have in common? Oh, 33 and 44 are divisible by 11. 11 multiplied by what will give us 33x? It's 3x. 11 multiplied by what will give us 44? It's 4. So same thing as before. This one and this one have what in common? 3x plus 1, 3x plus 1. So 3x plus, not plus 1, but plus 4. 3x plus 4 goes out. When we take 3x plus 4 from the first one, then what's left? X. When we take 3x plus 4 from the second one, then what's left? 11. That's it. We are done with this. So this what we see is called factorization by grouping. Now, if we go back to our question, x squared plus 8x plus 15. The only way to solve this one is by using the following method. And it's pretty easy, trust me. You just have to ask yourself two questions. Question number one, what are the two numbers that we multiply to get 15, positive 15, and if you add those two numbers, then you will get 8, positive 8. Okay, then let us try. What are the two numbers we multiply to get 15? I can multiply 1 by 15 to get 15, but 1 plus 8 will not give me, 1 plus 15 will not give me 8, right? So this doesn't work. What if you try 3 multiplied by 5? Will that give us 15? Oh yes. Now let's try to add them. 3 plus 5, it's equal to 8. That's exactly what we wanted, right? So our numbers are 3 and 5. Now the thing is, there is short way to do this and long way to do this. Short way is x and x. What is our first solution? 3. So we copy positive 3. Positive 3. What's our second solution? 5. So we copy positive 5. That's it. We are done. So we need to find two numbers that we multiply to get 15. If we add them, it will give us 8. The two numbers are 3 and 5. All you need to do after that is x plus 3 and x plus 5. With that, you are done. You have it in factorized form. But I will show you a longer way as well. So the same question but longer way. It's very important that we know how to do it by expanding the middle term. So x squared plus 8x plus 15. So again, we ask the two numbers that we multiply to get 15, and if you add them, you will get 8. We already know the numbers are 3 and 5. What that means to us is that we split the middle term. Instead of writing 8x, we write positive 3x and positive 5x. Right? Because positive 3 and positive 5 is positive 8. We did not change anything. Okay, x squared, we just copy that. 15, we just copy that. The way we solve this is using grouping, right? Because is that what we talked about here? Grouping, right? So we use that method to solve this. Okay, the first two, what do they have in common? X, what's left? X multiplied by x is x squared, x multiplied by 3 is 3x. Now from the second one, 5 multiplied by x is 5x, 5 multiplied by 3 is 15. Finally, the one on the left side and the one on the right side, what do they have in common? X plus 3, so x plus 3 goes out. Now what's left from the first one when x plus 3 is taken away? We have x left. From the second one, when we take out x plus 3, we have 5 left. All right. So you can write this as x plus 3 and x plus 5. And that's it. So now we know how to do it by using the grouping method as well. Alright guys, in the next few minutes we will do some practice questions. Alright, so the remaining few minutes of the lesson we will be doing these 3 examples, and I believe that by explaining all 3 of the examples we will cover everything that's important for this lesson. So let us focus here on example 1. In this example we try, does basic factorization work? No. Difference between two squares? No. Is it a perfect square? No, it is not. Okay, then our hint is, what are the two numbers that we multiplied to get 28, and what if you add them, those two numbers, that this time we will get negative 11. Be careful, we have to look at the sign of the number. It's very important. Okay, now what are the two numbers to multiply to get 8? To get 28, you can multiply, for example, 2 multiplied by 14. 2 and 14 will indeed give me 28. But can I get 11 using 2 and 14? 14 minus 2 is 12. Doesn't work. Okay, let's try another option. For example, 7 multiplied by 4 will give me 28. Excellent. Now be careful. How do I add them so that we get negative 11? Negative 7 multiplied by negative 4 will still give me 28. But negative 7 and negative 4, when we add them, it will be negative 11. Oh, so the numbers that we needed are basically negative 7 and negative 11. So I told you, shorter way would be x negative 7, x negative 11, x negative 7 and x negative 4. With that we are done. So we just copy negative 7 from here and we copy negative 4 from here. Now again, if we want a longer way, it would be x squared. Instead of minus 11, we write minus 7 and minus 4x, and then we copy plus 28. We perform the grouping here. From these two, they have x in common, x minus 7. The other two have 4 in common, and then minus 4 by x minus 4 multiplied by minus 7 is 28. Finally, x plus 7, x minus 7, x minus 7, x minus 7 goes out. Then what's left from the first one? X. What's left from the second one? Negative 4. That's it, we are done. So basically, this one was solved in one step here, and this is using factorization by grouping. All right, example 2. What is important about this question here is that all of them can be simplified. We can factor something out first. What do we mean? This one and this one and this one are all divisible by 3, right? So 3 goes out. Okay, what's left then in brackets? 3 multiplied by x squared. And then 3 multiplied by 4x. And then 3 multiplied by minus 3 multiplied by what to give us 63? It is 21. All right. So what we have to do is to factor x squared, 4x, and minus 21. What do we have here, guys? What are the two numbers that we multiply to give us minus 21? And if you add those two numbers, you will get 4. Okay, let's try. And yes, indeed, the first option that comes in our mind is 7 and 3, right? Because you know that 7 multiplied by 3 will give you 21. Remember, I want my answer to be minus 21. So one of the numbers is negative, either 7 or 3. But then which one is negative if I want to add them later and to get 4? Oh, it means that my 3 is negative because 7 and negative 3 will give us 4. Perfect. So the numbers are 7 and negative 3. You can say immediately x plus 7 and x negative 3. Very important thing. You remember the 3 that we factored out in the beginning? Please write it down. Okay, so that we have the correct answer. So this is the final answer. If you want to do it by splitting the middle term, you can refer to the previous example. All right, finally, the last example for today. Step 1. What do we notice here? Can we factorize something out first? Are they all divisible by something? Oh yeah, x squared goes out. X squared multiplied by what will give us x to the power of 4? It's x squared. X squared multiplied by what will give us 2x cubed? It's 2x only. X squared multiplied by what will give us x squared? It's 1. So what we have to do is just to find two numbers that we multiply to get 1. But if you add those two numbers, you will get positive 2. Okay? What multiplied by what will give us 1? But if you add them, you will get 2. Easy, right? I can hear you shouting. 1 multiplied by 1 is equal to 1. And 1 plus 1 is equal to 2. Excellent. So our numbers are 1 and 1. So we said x positive 1 and x positive 1. With that, we can say that the lesson is over and we have completed successfully the three questions from the beginning of this revision. All right, that's it for today, guys. I hope it was clear. With this, we have covered different factorizations using the rule. Two numbers we multiply to get the third term, and if you add them, you get the middle term. In the next video, we will explain questions where a is not 1. So for example, 2x squared plus 5x plus 3. This cannot be factored using the way we explained today. It will be covered in the next video. See you next time. Bye.